Welcome, everybody, to this BioIT World Symposium, Improving IT Infrastructures for Life Science Organizations. We're grateful to SGI and Intel for their support for today's webinar, which has allowed us to bring free registration to everybody on the call. We have three fantastic speakers. Let me just first set the stage here. With the increasing strain on both conventional drug development and next-gen sequencing and molecular modeling technologies placing on life science IT infrastructures, there's obviously an ever-growing need for improvements in the way that organizations, both academic and industry, utilize and leverage data for optimizing development outcomes and biomedical research. The purpose of today's web symposium is to examine some of these rising challenges that humongous data sets are creating for the life science industry, discuss better ways to manage these challenges through improving on technology infrastructures, and to provide some insight into some of the cutting-edge solutions that are currently available. And you're going to hear about one or two of those in particular towards the end of the web symposium. We have three spectacular speakers for you with PhDs in environmental chemistry, molecular pharmacology, and theoretical quantum chemistry. So a pretty high-powered symposium, to be sure. A little later in the broadcast, you'll hear from Jill Matsky, the Director of SGI Server Product Marketing. And we'll also welcome an old friend of ours, Martin Leach, Executive Director of Merck Research Laboratories IT. First off, however, it's a great pleasure to introduce Jack Collins, who will set the stage for the symposium. Jack is the Director of Advanced Biomedical Computing at the National Cancer Institute in Frederick, Maryland. He's trained in mathematics and theoretical quantum chemistry, as I mentioned, worked previously at SRI International and the Molecular Research Institute as Director of Computational Biology before joining NCI. His forte is developing high-performance algorithms for data-intensive problems in the areas of genomic analysis, proteomics, molecular modeling, and systems biology, to mention just a few particular key areas. He has and continues to serve on a number of supercomputing steering committees, including the HPC User Forum and Microsoft's Technical Executive Advisory Committee. Jack, we're really grateful you could spare the time for us, and we look forward to your presentation.
Thank you. I'm going to kick this off, and basically what we're going to talk about is the challenges that we're facing here at the National Cancer Institute. We have a lot of different technologies coming in. We have the expertise to actually do the analysis, to run the computers, to worry about the IT networks and everything. So we see it from a fairly broad perspective. So today I'm going to try to actually give a fairly broad idea of what the problems are, what we're seeing, a view from both the IT side and from the user side, because I'm kind of both on that, as well as where I see this going and some of the solutions we might have to have. I don't have a lot of answers, but I certainly have a lot of questions. What we try to do also is we look at not just what's coming in with next-gen sequencing, which I'll talk about quite a bit, but imaging data, bioinformatics analysis of that data, proteomics, actually collaboration, which I would say CA-BIG is the ability to interoperate, nanotechnology, and especially as we look at that as therapeutics for cancer or diagnostics, and then computational algorithms and what we need to do. So I just want to also up front say that cancer is the focus that we have here, all the technologies that we try to integrate, all of the Institute's various research programs. So again, just, there's an urgency to what we do, and supercomputing is certainly a way to help us with that. One of the things that's happening is the science is really driving, science is driving the company.